Red and I started this journey about 2 years ago to turn raw land into a fully functional off-grid homestead. We are almost done with the house and we are now living in the home that we built and designed ourselves. There are so many things we love about this house, from the overall design to the concrete accent walls, earthen floor, and large south-facing windows. From the beginning, we knew we wanted to incorporate passive design strategies in our home design. The results have surpassed our expectations. Our house is being heated entirely from the sun and maintaining very comfortable and stable temperatures. In this video, we will be talking more about the passive design of our new home and showing how it is performing this winter.
An important part of our passive solar design is these southward facing large windows. So all along the south side of our house, we have big windows. These are 5-foot tall windows. Of course, we have the overhangs, and so the overhangs protect the house from the direct sunlight in the summer, but in the winter time, the sun is lower and the sun comes directly in and shines into the living room here, and it heats up the floor and the walls. It heats up all the thermal mass in the room. So this has been incredibly important to thermal regulation in our house, and it's how we're able to get by without any kind of a heater in the wintertime and still be extremely comfortable. So each one of these windows, really, when we open these windows, I feel like I'm turning on a heater. Every time I open a curtain, I'm turning on another heater, because that's really what they feel like. All this sun that comes in, when you stand in the sun, you can feel the intense warmth of the sun coming in, and it's just free heat, and it's really amazing. So you can see the difference, and so like from a part of the floor where the sun has been shining compared to a part of the floor where it hasn't. So this is our earthen floor. It has great thermal mass here. And so this thermal mass is going to be soaking up the heat of the sun. So right here, I'm pointing kind of in the middle of this sunbeam here, and we're 75 degrees. And if I come over here to where the sun hasn't hit yet, we're 64 degrees. So the sun, as it comes in, is just heating up the floor. The floor is absorbing all of that heat, and then in the evening tonight, it'll release that heat and keep our house a really steady temperature through the night. Last night we had a really cold night outside. It was down well below freezing, about 25 degrees. The house only decreased in temperature 3 degrees over the night. It's amazing. Overnight it only dropped 3 degrees in temperature, even though it was well below freezing. And that's because all of this thermal mass is releasing its heat through the night and keeping us warm. So the type of window that you use in a passive solar design is really important to the performance of the home. So we used a window that is double pane. Triple pane would be even better, but double pane was a reasonable price point, so we went with double pane windows. We used as many windows that didn't open as possible because they leak less air. We just put in a few carefully placed opening windows because they're a little less efficient. But one really important aspect of all of the windows that we put on the south side is that they do not have the UV coating. So when we were considering our windows, we read that it was beneficial to leave off the UV coating so that you get more heat in through the windows, that UV protection also blocked out some of the heat. And so it's good we learned that, and we decided to go ahead and order all of the windows on the south side of the house without the UV coating. That was a special order that we had to make. The only glass on the south side of the house that has the UV coating is the sliding glass door. And so I'd like to do a comparison real quick to see what the difference is between sun that's coming through the sliding glass door that has the UV coating and sun that's coming through a window without the UV coating. And there's 2 spots here right now where the sun is hitting the floor. And so we'll take a temperature reading off of both spots and see what the temperature difference is. So I'm going to start on the coated side over here, the uncoated side. So this is the non-UV coated windows, and I'm getting about 81.5 degrees right there. And then if I move over here, you can visually see that it's a little dimmer just because of that UV coating, and I'm getting about 75 degrees. So we're about 6.5 degree difference on the floor between the UV coating and the non-UV coating. So we're getting a lot more heat through those non-UV coated windows. So that was an important decision to make. There are some drawbacks to having the UV coating. It can prematurely wear out carpet and that sort of thing. But since we're only getting direct sun through the windows for 5 or 6 months out of the year, we didn't think that was too big of a deal, and certainly the extra heat that we got was worth the trade-off. It's interesting, the arc that the sun takes through the sky in different seasons is not a linear line. It's not a straight line. It's a bell curve. And so in the spring and in the fall, it's very steep. So it's changing very rapidly. And so the light that comes in our windows pretty much goes from full on to full off within a couple of month time frame in the spring, and the same in the fall. It's in the April-May time frame in the spring. And then in the fall, there again, it changes very rapidly. And then during the winter and the summer, it's kind of very slowly changing. And so you get that full sun. So it's just interesting. It doesn't just like the shadow, the amount of light that comes in doesn't slowly change over the months. It all happens rather rapidly when you're on the steep side or the steep downside of that bell curve. And here's a look at our poured concrete walls. We poured these for thermal mass and they're working great. So it's about 3 o'clock in the afternoon. As you can see, there's direct sun hitting these. As the sun sets, that sunbeam kind of moves across the wall and heats up the whole wall. So right now in the house, it's 73 degrees. That's the ambient temperature. And you can see right here where the sun is hitting the wall, we're at 81 degrees. So the wall is warmer there. It is soaking up that heat of the sun and storing it like a battery stores energy. And then at night, when the temperature in the house starts to go down, it'll start to release that energy to keep the house warm at night. And so here's kind of in the shadow, just by the sunbeam, we're at 77, 76 degrees. So still warmer than ambient temperature there. Just for some context, we live in the high desert of Arizona, and that means we see some pretty extreme temperatures. In the summertime, we see temperatures rising up to 105 degrees. It gets very hot. And in the wintertime, it gets very cold. Almost every night in the winter, it's below freezing, and we've seen temperatures as low as 5 degrees. Because of this high desert climate, we also see huge 24-hour temperature swings, so very hot in the day and very cold at night, which actually works in our favor most of the time. In the summertime, the cool nights allow us to cool the house down, and in the wintertime, the warm days allow us to heat the house up. The exterior of the house has many layers, and we took a lot of time to seal up all those layers very well. We wanted to minimize energy loss. As far as the insulation we used, the entire exterior of the house is covered in foam board. The walls are covered in 2-inch, and the roof has 2 layers of 1.5-inch installed with the seams staggered. This virtually unbroken layer of foam seals in the house like an igloo cooler. This eliminates the thermal bridging that usually occurs along the length of all of the studs and roof beams. The foam is installed with a reflective coating facing out, and this is beneficial since there's also an air gap between the exterior metal siding and the foam. We also use fiberglass batting on the inside, in the roof, and in the walls, and that gives us a total R value of 40 in the ceiling and 20 in the walls. The R value numbers don't sound very impressive in and of themselves, quite mediocre actually. But that just goes to show how R value isn't a very good indicator of how well a house will perform. There's so many other factors. All the thermal mass in this house, the orientation of the house, the windows, the envelope of foam on the outside that cuts out the thermal bridging, the gap between the exterior siding and the house, the reflective layer being pointed out, the white roof reflecting the sun back up into the atmosphere. All of these different features and many others that I haven't mentioned go together to contribute to the thermal performance of the home.
So here we are. Now it is December 12th. It is 9:45 in the morning. We got down to 69 degrees last night in the house. We're at 72.5. We've had some sun this morning, which was a surprise. We thought it was going to be raining first thing in the morning, but no rain so far. And the sun is heating up the house nicely. So we have 3 days where we're expecting temperatures highs in the 40s. And as long as we have good sun, the house should stay a really nice temperature. And even without the sun, I don't think it would get too bad. So interested to see what it does. We're supposed to get rain later today and then possibly some snow tonight and then 2 more cold days. So we'll keep you updated on how this passive design does with this kind of cold temperatures.
Well, it's about 7:30 in the morning. The sun just peeked out over the horizon about 10 or 15 minutes ago, and it shines right in through these big windows, which we have open to receive the sun. Each one of these windows is like a little heater that lets in the heat of the sun to warm up our house. As soon as we open these windows up in the morning, the sun comes through and shines on both of our poured concrete walls, so it's already hitting that thermal mass and they're starting to absorb the heat. So it's early morning. We had a cold night last night. It's about 25 degrees outside, and inside it's 65 degrees. So we have a 40-degree difference. And yesterday was a cloudy day. We started off a little cooler than normal, didn't have as much heat as normal. And here's a quick look from the master bedroom. You can see the sun shining in through the window on the other thermal mass wall, so heating that up first thing in the morning. When we went to bed last night, the house was at 68 degrees, and overnight it only dropped 3 degrees to 65 degrees, which is what the temperature is right now. Even with those below freezing chilly temperatures outside, we only lost 3 degrees overnight. It stays amazingly stable.
So one more update today. We're 72.9. It's about 4 o'clock. We got cloudy this afternoon, so not a lot of heat coming in, but not too bad. Pretty nice day. We'll show you tomorrow. I think our high today was about 44, so very cold day. Supposed to be a very cold night tonight. We'll see how cold we get, and we'll give you another update tomorrow.
So here's a little update on our temperature since yesterday. Last night we had a super cold night. It got down to 14 degrees outside, only down to 64 degrees inside the house, so 50 degrees warmer inside the house. Then outside it only dropped 3 degrees last night from the time we went to bed to the time we woke up in the morning, so that seems to be a typical amount. And right now, outside here in the sun, it's 46 degrees outside, and it's 74 degrees inside, 73, 74. So even though it's a cold day outside, even though the high today is going to be around 46, maybe 47, we're still gaining temperature inside. We got down to 64 degrees inside last night, and it's already up to 73, 74 degrees. So we're gaining temperature, even though it's pretty cold outside. Well, we've been having some problems with our well. The pump has been acting funny, and in fact, it's acted a little strange ever since we put it in. We were really excited about the pump at first. It's a Grundfos pump. It's a German make, very high-end, super nice pump that we were expecting many years of good service out of. It has some cool features in that it can run off different voltages, including, normal solar voltages, 12 to 48 volts. It can also run on AC in the 120 to 240 range. So it's very versatile, and we thought it might be nice to run straight voltage from the panels or something along those lines. So it's a really cool pump, and we were excited about it at first, but unfortunately we've had trouble with it. It has a built-in soft start, which is also nice for solar systems, but it's always been real slow to start, and in fact sometimes we've had to wait several minutes for it to kick on. We've had it looked at one time, and then the other day it just stopped working. So we called the well service people out, and they determined that the pump was bad after only 2 years. Very disappointing. As an aside, the truck also stopped working at this time. The batteries have been going dead, and so here I am trying to clean off the terminals, hoping that was a problem. So I cleaned them off really well. Turned out later on I found out these batteries are bad after only 2 years. It's crazy. It's very disappointing, hoping to get maybe 5 years of life out of these, but no, after 2 years they're shot. Well, back to the well pump. After only 2 years it was shot as well, and turns out it's been 2 years and 2 weeks since it was installed, and the warranty only goes 2 years. And so we tried to get it warrantied, and the factory refused. So we had no option but to have the well crew pull out the old pump and install a new. Fortunately, the roof on the well house is designed to come off real easy, so it wasn't too much trouble to take the roof off so that they could get their crane in here and pull the pump. It was a difficult decision to decide what type of pump to go back in with. We're very disillusioned with Grundfos and decided not to use them again. So we talked to the well driller, and he recommended another brand that they'd had really good service from and that are better at honoring warranties that might be a little past. And so we decided to go with a different brand and also go with a pump that uses AC only. It's a 240 volt pump, and it also doesn't have a soft start, but we feel like that the system will be able to handle it just fine. This new pump also has a little bit more capacity, so it puts out more volume. It's a 1/2 horsepower, 7 gallon per minute pump, which is a little bit higher capacity than the Grundfos. The driller had the new pump in stock, and so they were able to come back out and install it pretty quickly. They actually came back out on a Saturday for us and spent the morning putting that in, so we were only out of water for about a day and a half. Once they had the pump set, I was able to put the roof back on. Not too big of a job. Took about maybe an hour and a half to get the roof put back together, get the insulation put back up, and get it all buttoned up again. The cost for the new pump and the installation was a little less than we expected. It was $1,700 total, and we split that between the 3 families that are living here on the property. One nice thing we found out too, when they replaced the pump, they checked the depth of the water level, and it's essentially the same as it was when we put the well in, if anything a little bit higher, so the water level out here at our property hasn't changed. Next week, I'll be starting on the shower stall in the master bathroom. It's the last major project in the house, and we've never done one, so it's a bit intimidating.
Thank you all so much for joining us and wishing you a very Merry Christmas.